Hi, everyone. I'm really happy to be here today, visiting a city of my dreams while talking about something I totally love. For today, we will be talking about how to develop a plugin for Android Studio. First, a quick introduction about myself. My name is Ahmed Ali, and I have been passionate about coding for my entire life. I have started my journey at the age of 14, back in 2012. Over the years, I had the opportunity to work with various companies, most of them remotely. And today, I'm a software engineer at Infinim. Throughout the years, I can't hide my love for building tools for developers, and I wanted to share this passion with you today. So we will be learning about plugin development. So one of the tools I recently built is a plugin for Android Studio that can write documentation for various code elements, like classes or functions. Here's how it looks. I added a button to the right-click menu that says Document this code. Once you click it, it sends the code to Gemini, gets it back, generates the documentation, and writes it back on your code. And let's discuss what we need exactly to build a previous example. The first thing, we need to register a button in the context menu so we can click on it. That's where actions come in. Actions are the platform's way of adding interactive components to the IDE. Then, we need to access the code that we are clicking on. With this action, we need to check what type of code it is, like whether it's a class, it's a function, or something else. And read that code so we can send it out to Gemini. That's what we will be diving into BSI, Program Structure Interface. And then, we need a way to manage dependency injection and load classes only when needed. This is where services comes in play. The last thing, since our plugin will mostly be communicating with an API, we are dealing with the long-running operations. We need to handle these in the background and then switch back to the UI to display the results. This is why we need to understand how the threading model is working in the IntelliJ platform. But before we jump into that, we need to explore the different types that we can create for a plugin. The first type can be custom framework integration. For example, if someone used Flutter before, you realize that you need to download and install a plugin designed just for Flutter, so Android Studio can support it. Without this plugin, Android Studio won't recognize or support Flutter at all. And this takes us to the second type, custom language support. The same as Flutter, if you want to work with it, you need to install a Dart plugin, which is the language used by Flutter. You need to install this plugin to enable Android Studio to understand and work with Dart language seamlessly. You can write and edit and debug code. Third thing, we have tool integration. Tool integration plugins add new tools or enhance existing ones in Android Studio. A great example of this plugin is the one that we mentioned in the beginning, that we can generate documentation for any code element. And then we have theme plugins, allow us to customize the look and feel of the IDE. You can have your own colors, you can have your own theme with downloading these plugins. And the last type are UI add-ons. And these plugins are all about extending Android interface for Android Studio. They allow you to add new panels, toolbars, or other UI components, which can enhance the usability and the functionality of the IDE. This can be practically useful if you need a specific feature or tool to be readily accessible for your daily work. Now, we need to know how to create a plugin. Before we get into specific, there is something I want to mention. Plugin for developing for Android Studio was on version 1 something for all of these years. However, just last month in August, they created a new version 2.0. It's a huge release, they deprecated a lot of stuff, and they added a lot of feature. And today we will just focus on 2.0, even if the documentation is not completely written yet. So, what exactly we need to do this? To start developing a plugin, you need to do two things. IntelliJ Community IDE, which is a free IDE, and a plugin called DevKit. This is all the stuff that you want in developing a plugins. And make sure always to use the latest versions for both of them. So once you have the plugin installed and the IDE installed, you can just go and create a new project. You will have a new type in the wizard. You will have something called IDE plugin. Just select it, set your information, your name, your package name, your path, and everything, and you are good to go. And this setup will create a project structure that's very similar to what we are used to see in any typical Gradle project. So let's see how this looks. So we can see, you will notice a familiar things here. A Gradle folder containing your wrapper properties, an src main directory that houses your code, and of course, build.gradle and the Gradle.properties. So same things again as any Android project. Now, here's where things get a bit different. Inside the main directory, you will find the resources folder. Within that, there is a directory called meta information, which contains a file named plugin.xml. So what exactly is this plugin file? To put it simply, it acts very much like Android manifesto file in Android development. This file contains the crucial information about your plugin and how to make it usable from other plugins. It's a critical file, and we will revisit it multiple times later in this talk. Now, let's configure the plugin. In the build.gradle file, you have the same blocks we usually see in any Gradle project. Inside the repositories block, there is the IntelliJ platform extension, which you can add default repositories and default dependencies that might be required by your plugin. Next, there is another platform block where you can set up your different IDE versions, specifying the range with since and until specific builds. In the dependencies block, you can add any library you want to use if it's designed to work with JVM. You can also use IntelliJ platform inside it to configure which target build you want. For my configuration, I choose Android Studio with a specific build version and added the necessary plugins like Java and Kotlin, so I can understand these codes. This plugin configuration after the new version 2.0, which is completely different from the previous versions. So back again to our main components. As we mentioned, we need actions to add buttons to the right-click menu. So let's dive into actions and learn more about how they work. OK, so what exactly are actions? Actions are essential for adding interactive components to the IDE. They can be added to menus, toolbars, or any other area that the platform supports. For example, one of the action classes handles the file open or any menu that you can see in the screen for Android Studio or any IntelliJ platform. So how to create this? Start by creating a class that extends an action class. Then you will see a register action option that pop up in the IDE. Choose it, and this will open a dialog that lets you choose when this action can be shown. You can choose whatever menu you want. But a best practice, I will say, since the IDE offers a lot of options for registering elements, and the documentation may not cover everything, I would recommend as a hands-on approach, and you should be using this for everything regarding the plugin, I usually look into IntelliJ source code, find the areas where I want my elements to be shown, and see how similar features are implemented. Then, I replicate the same approach with my own code. It might seem a bit hectic, but it's effective given the complexity of the IDE. In your class for action, you will primarily work with three main functions. The first one is update. And this function is responsible for updating the visibility and the enablement state of your action. Here you define the logic that determines when the action should be available. For example, if you want your action to only appear when right-clicking on a class or a function, you would implement that logic here. Second, you have action performed. And this is where you write the code that gets executed once the action is triggered. Essentially, what happens when the user clicks on that action. The last one, get action update thread. It was introduced in 2023. And this function lets you specify which thread your action should run on. You have two options here. You have event dispatch thread, which we call EDT, which is basically used for UI tasks. And then you have BGT, background thread, used for operations that interact with BSI elements or any file system approach. We will talk about threading at the end. So, but here we want to know choosing what should we do to choose the right thread when we are working with the update function. So basically, if you are working with BSI or anything that have heavy calculations or something that works with the file system, you should go with BGT. But if it's just updating something in the UI, you should always go with EDT. OK, so let's jump back to our main example for documenting code. So this is our action. The update thread is set to background thread because we are working with the file system. Again, we will discuss this when we cover BSI. And then we have update function. I'm doing some BSI work. And BSI is the main tool that you use to analyze different sectors of the code. And then in action performed, we essentially initiate the action itself. OK, so by now, we know that what actions are. Now we need to know how to use a tool that analyzes the code elements and load their body when needed. To achieve this, we need to dive into program structure interface, which is BSI. So BSI is a critical layer within the IntelliJ platform that handles parsing files and creating both the semantic and the syntactic code models. In simpler terms, BSI is how the IDE recognizes different code elements, like identifying whether this code element is a function or a class, and so on. And to understand BSI, we need to dive into two main components, BSI files and BSI elements. A BSI file is the root structure that represents the content of your file. It acts as the entry point for your understanding to the file structure. The BSI file class is the base class for all BSI files. However, you typically won't work directly with BSI. Instead, you will use more specific classes based on the type of the language that you are targeting. For example, if you are working with Java files, you will be using BSI Java file. If you are working with Kotlin, you will be using KT file, and so on, with any different language that you are targeting. Let's move on to the second key component, BSI elements. BSI elements are the individual building blocks that represent the different parts of your source code's internal structure. These elements are provided by the IntelliJ platform itself and are used to explore and interact with finer details of your code. Anything from a white space to classes or functions is considered an element. And just like with BSI files, you typically want to work with these base BSI class. Instead, you will often work with more specific subclasses, like KT named function, which represents a named function in Kotlin. These subclasses are how the IDE provides support for different languages. So have you noticed something here? Or let's take our example here first. I'm getting the BSI element from the action event. This is the first thing. I then check if the element is a Kotlin named function or a Kotlin class using is. And then if it is, I can read the element code by calling element.text. And you can call anything on the BSI. You can reach the modifiers, you can reach the body, you can reach anything. Then, have you noticed something here? This is basically how we add support for different language. The plugin should just implement their own suite of BSI elements and BSI files. Now, we finished BSI and we finished actions. Now we need a way to organize our functional classes and maybe have something like dependency injection, allowing us to load classes on demand. So let's move on into services, or what I like to call DI for plugins. So a service is a class that can be loaded on demand whenever they are needed. This is because the IntelliJ platform ensures that each device has only a single instance loaded, effectively making it a singleton. But there are two levels of singletons with this context. Application level, also known as global singleton service. This type of service works across the entire IDE lifecycle, covering the whole scope of the application. And then we have project level singleton. This type of service is more specific and operates within the scope of the individual projects. Each project running or using the plugin will have its own instance of the service. In addition to these two levels, there are also two types of services to consider. Light services, these are services that are private to your plugin and aren't exposed to other plugins. And then we have non-light services. These are the services exposed, and they can be accessed by other plugins, making them available beyond the scope of your plugin. Then let's talk about how to create and use these services. You start by creating a regular class and annotating it with add service. If it's a project level service, you will need to include the project parameter in the constructor, which is the IntelliJ platform will automatically inject. You don't need to do anything extra for this. If it's a non-light service, you don't need to use a service annotation, but you need to register the service in the plugin XML file. In this example, I have write it as an interface and implementation classes to demonstrate how binding in the plugin XML is working. However, you can implement non-light services without using an interface if you prefer. If you want to retrieve an application level service, you simply call getService. For a project level service, you use the same method but within the context of a specific project, ensuring that the correct instance of the service is provided. One thing to note, constructor injection, you shouldn't be using it. Always call getService only when needed. Okay, let's revisit our main example again. Here's our service. It's a light project service injected with a parameter, as you can see. Let's ignore the scope for now. We will talk about it when we jump into threading model. First, I read the BSI element. I check if it's a function or a class. Then I make the API call. Then I create a new BSI element and add the code and the documentation as text. Now, the only remaining thing we need to learn is a threading model. This will allow us to run background tasks, load some data, and then write it back in a thread-safe way. And this is really crucial because we don't want to be freezing the IDE. So basically, IntelliJ or Android Studio or any IDE that is built on the platform is at its core a Java Swing application, which means it has only two types of threadings. We have EDT, Event Dispatch Thread, also commonly known as the UI thread. This thread is primarily responsible for handling UI events, such as reacting to a button click or updating the interface. And it's important to note that the platform also uses EDT for writing data. So if you want to perform any writing operation, they must be done on EDT. This is very important, and we will revisit it again. And then we have the other type, BGT, background thread, used for performing long-running and resource-intensive operations, or the background task. Unlike the EDT, the BGT is where you should handle tasks that could take time, such as processing a file, network calls, or other intensive operations. And starting this year, IntelliJ has made coroutines the recommended approach for threading in a plugin development, preferring them over traditional threads. We can go over a lot why they did this, why coroutines is better, but we all know the reasons because we're already using them in Android every day. And when we talk about coroutines, we need to explain three things: dispatchers, scopes, read and write locks. For dispatchers, we have the default IO, the unconfined, and we have EDT and main. Both of them are the same dispatcher, they just have different names. And usually, IntelliJ recommends to go with the EDT naming because it's just more consistent with their setup. Then we jump into scopes. The IntelliJ platforms offer multiple scopes, and when we have application and the project scopes, being the most common and the most used before. However, now they are deprecated, and a preferred approach is to use services scopes. And services scope is tied to the life cycle of a service, making them more efficient and reliable for managing coroutine tasks. And then we have read and write locks. In a multi-threading environment, read and write operations must be carefully managed to avoid conflicts. Let's imagine that you have a BSI component or a part of the code, and there is a writing operation happening to it, but you want to read that element. If the writing operation is happening, it should cancel the read, because this will have some conflicts. So the platform provides two types of locks. We have writing allowing read action, WARA, prioritizes the writing operation, which means it will cancel the read operation if there is a writing happening, and it will retry again to make sure it's happening. And then we have a different strategy, writing blocking read action, WBRA. And this will prioritize reading operations, which means blocking writing actions until the reading is complete. So let's jump back into our service again. Now, we understand everything about the service. We take a project as a parameter to service because it's a project level service. We also take a coroutine scope, which will be injected by the platform itself. And this is what we refer to the service scope. Then we use the scope to launch a new coroutine and execute a read action. This is a WARA, writing allowing, and a suspend function that may try multiple times until the read is successful. Next, I switch the context to use IO for background tasks, and then switch back to EDT for writing actions. Because as we mentioned, all write operations must be done on the EDT, or main one. So what exactly did we learn? We went through actions to register the buttons, learned about BSI and to analyze the code, used a service to load the class on demand. We also leveraged its scope for better threading using coroutines. And that's how you go from an idea to IDE. Next, let's jump into Android Studio. I want to show some use cases. So this is IntelliJ. This is the plugin. You can see on the left-hand side, this is literally the same structure as we have for any Gradle or any Android project. It just, the target is different. And here we have the code or action that we mentioned before. And then we have the service. And you can see here that I'm injecting the project. I'm injecting the scope. I'm injecting the project because this is a service project level. And I'm injecting the scope because I want to use scope services for coroutines. And then normally I'm launching the scope. I'm calling the Gemini service, which is another class I wrote. And this is, by the way, is just, let's go into this class. This is basically a Ktor client that talks to an API or a RESTful API that talks with Gemini. It's not magic. You can just use any JVM library that you might use in Android. Of course, you cannot use Retrofit because it's targeted for Android, but you can use Ktor, which is really fun. So get back to the service. We are doing a read action, so we can read the element. We are checking if the element is a KT named function or a class. And then I am switching the context for dispatcher, so we can call the API in the background. I am getting the new text from the API, switching back to main, so I can do the write operation. When you click run, this will open a new instance of Android Studio, because you are developing a plugin for Android Studio. You are targeting Android Studio as your target here. You can see that I have a new option here, which is called Document this code. Once I click it, it will load for a bit, and it should write the documentation. And yeah, it wrote the documentation for all the functions here. I wrote another plugin just to show. If you click here, if you go to Show Context Actions, you can see that we have a new item, which is called Suggest Better Names. Once you click over it, it will suggest different names for these variables, because we all know all developers are really bad when it comes to naming. So I will say, OK, I will go with coordinates. It did a refactoring naming, so it changed it here and here. Let's see how I implemented this plugin. So the first thing, we need to have an action. And here I'm using something called intention action, which is added to the context one. And you can, again, do the same thing. This code is available on GitHub again, so you can check it. Here we have a different function called is available that you say when exactly this should be shown. So I think it's pretty easy to understand it. And then I am calling another service, which is called name the service. And again, it does the same thing. Read action, getting all the element name, element text, sending some API calls to Gemini, loading the body, doing some processing, switching to EDT so we can do the writing operation. And then here, the only different thing, I didn't do a write action because I didn't want to change it in a specific area. I wanted to change it everywhere. So there is a rename processor that is written by IntelliJ, and you can just reuse it. So this is basically how you do anything with the plugins. So getting back to our presentation. There are a few things that I didn't mention in the 4 key components, because they are not necessary to have. But let's say that we want to cover UI. What should we do? You have three options. You have a swing, and mainly swing is the fundamental tool for this application because it's written over it. But for me, it's not the most fun choice. I didn't like swing when I used it in college, and I still don't like it. There is another option called Kotlin UI DSL, which is a declarative way, just like Compose. You have a state, you can bind it to the components. But what about Compose? Can we use it? We will know this just in a few minutes. But let's check Kotlin UI DSL first. It's a declarative UI toolkit. And you can bind components to a state, similar to basic concept of Compose. It looks really good and easy to learn. However, it doesn't cover everything. It's mainly used for dialogues and panels. Sometimes you will still need to jump back to swing. So let's talk about Compose. The answer is not straightforward. Compose can technically run with the swing. We have seen it multiple times because it runs on desktop. But why is not that simple? The problem is that you need to match the look and feel of a swing in the plugins platform and to make it can be integrated properly with the plugin system itself. This is not an easy task. So officially, Compose is not supported. However, there is a project called Jewel that brings the swing look and feel as themes for Compose, making it useful for developing a plugin. And there is a really good talk from DroidCon London about this that I would suggest watching if you are deeply interested in this topic. Using Jewel might be a good option if you are testing a plugin, but it's not recommended if you want to go production with your own plugin. You will be on your own if you choose to go with Compose. There is no enough resources about it. And the last thing, we need to know how to learn more about plugin development. So you can go with the docs. This is a very good entry point. However, the plugin is so big. The whole platform is so big. Imagine that you can document everything in IntelliJ or JetBrains or any IDE inside that platform. It's kind of impossible. So it's just a good starting point. And then the IntelliJ community source code itself. Because, again, IntelliJ is open source. You can go to GitHub repo, checking everything, and see what you can do there. It seems in the beginning really hard to do. However, it's your best choice, believe me. And then you have a Slack community. I included the link here. You can join. It's a really powerful community. You have people from IntelliJ team answering you. So it's a very, very good thing to get invited and be there. And that's it. Thank you, everyone.